Hey guys, and welcome to the school station. In today's video, I'm going to be talking about radiation. This is from the AQA GCSE Physics 9-1 paper from the unit Energy and Energy Resources. In today's video, I'm going to be talking about radiation, which is part 3 of our energy transfers by heating series. Previously, in our last two physics videos, we've been talking about conduction and convection. The part 1 was conduction, where heat energy transfers in solids. Part 2 was convection, where heat energy transfers in fluids. And today we're going to be talking about part 3, which is radiation, which takes place through no particles. So this is what we're going to be focusing on today, radiation. So first of all, before we even get started, we have to think about what is heat energy. Heat energy is a high kinetic energy of atoms, molecules, and ions. So I like to remember this by always thinking about a kettle of water. So if we think about a kettle of water and we're heating the water up, you'll realize that it makes a lot of noise because the particles in the water are moving very, very quickly and it's actually producing high kinetic energy. Therefore, heat energy is basically when something is moving very, very, very fast, okay? So heat energy is a high kinetic energy of atoms, molecules, and ions. So now we're actually going to be talking about the definition of radiation. Radiation is the transfer of heat through no particles as waves. So the specific radiation that there is, that we actually all the time will talk about, is infrared radiation. Infrared radiation is what we absorb from the sun. So whenever you are, wherever in the earth, you're always going to be absorbing infrared radiation. It is why we can feel heat even though we are 150 million kilometers away from the sun. Visible light and infrared radiation are both part of the electromagnetic spectrum. So you'll always realize wherever you are that you're always on the earth, obviously, and you'll realize that the sun is actually you're always absorbing infrared radiation from the sun. Even if you can't see the sun, you're always absorbing infrared radiation. At the same time, you'll also realize that whenever you're in the sun, you'll actually see the sunlight coming into you. And these are the two main ways that there is actually transfer of heat as waves, okay? So visible light and infrared radiation, they both work through waves, okay? And this is actually part of the electromagnetic spectrum. So this may be very confusing to you, but do not worry, because now we're going to be talking about the electromagnetic spectrum. The electromagnetic spectrum are basically electro waves and magnetic waves, and these are basically the 7 main ways or the 7 main points of the electromagnetic spectrum. So over here you can see that the two things we've talked about is visible light and infrared radiation. And you'll realize that there are actually, however, 5 more things that there is. There are gamma rays, X-rays, ultraviolet, microwave, and radio waves. These are all waves. These are all different things that actually uses waves to make sure that we actually get the thing that we want to transferred. So we will also realize that over here we can see that the gamma ray has shorter wavelength, higher frequency and higher energy, while radio waves have longer wavelength, lower frequency and lower energy. So basically it is the complete opposite. So you guys might be very confused about wavelength and frequency. Wavelength is actually a measure of distance between two identical peaks, high points or troughs, low points in a wave. So basically the distance from this point over here to this point over here is basically the wavelength, or from this point over here to this point over here, that is the distance, and that is what you call the wavelength. Also, the same thing for frequency. Frequency is the number of waves that passes a given point per second. For example, if you were measuring from here to here, and we want to calculate how many waves can go per second, that is basically what the frequency is. So in gamma rays, there's a shorter wavelength. You can see that it's very, very small distance between the peaks and troughs, but it also has a very high frequency because you can see that per second, many, many waves are quickly going through. Okay, so that is basically what wavelength and frequency is. And the electromagnetic spectrum basically contains infrared radiation, which is what we're learning about today, and also visible light, which actually has all the colors because we always have seen light ever since we were born. The acronym to remember the electromagnetic spectrum is raw meat is very unsanitary except giraffes. So this is something you'll definitely have to memorize because it's very important to memorize the electromagnetic spectrum. And even though we may be looking at this more in the future, in our future videos, you still have to remember the electromagnetic spectrum. So I have to remember it using this acronym. RAW stands for, RAW has R in it, and R stands for radio waves. M stands for microwaves. I stands for infrared radiation. V stands for visible light. U stands for ultraviolet waves. X stands for X-ray, and G stands for gamma rays. So this is the way you can remember the electromagnetic spectrum. It's very, very easy to remember the acronym, and this will allow you to remember the electromagnetic spectrum. Now we're going to be talking about infrared radiation versus temperature. So how does infrared radiation depend on the temperature? Well, what you really have to remember is all these three main facts. The higher the temperature of an object, the more infrared radiation emits at a given time. So let's say there is two objects. So let's say a mug of warm coffee and let's say a laptop, okay? So you have a mug of warm coffee and a laptop. You may realize that the mug of warm coffee has a high temperature, which means that it will also emit more infrared radiation. So that's what you really have to remember. Another thing is, if an object has a constant temperature, the object emits infrared radiation at the same rate as it absorbs it. Again, if we have, let's say, a person, and this person is having a constant temperature, like fully constant, you'll realize that whatever they're absorbing from the sun, they'll also emit the same amount of infrared radiation. However, most of the things in this world is not constant, and this is why we usually might absorb some more infrared radiation than we emit, or vice versa. So usually objects are not in a constant temperature, but if an object has a constant temperature, then the object emits infrared radiation at the same rate as it absorbs it. And you'll be looking at an example of which object actually does have a constant temperature and, it's a perfect black body, which we're going to be talking about. When an object absorbs radiation faster than emits radiation, its temperature increases. So obviously, if we have something that is absorbing more infrared radiation from the sun, obviously its temperature will increase because they're actually gaining more heat energy and therefore they're becoming hotter, so the temperature is increasing. Now we're going to be talking about black body radiation. So this is what we were talking about earlier. So I was telling you guys that if an object has a constant temperature, the object emits infrared radiation at the same rate as it absorbs it. A perfect black body is basically an object that absorbs and emits all the radiation that hits it. It's basically perfect, and no other object emits or absorbs radiation as effectively as a black body. Okay, so this black body is basically like object that absorbs and emits all the radiation that hits it. It's very smooth and it's the perfect object to emit and absorb radiation. So that's basically everything we've learned today about radiation, and I hope you guys have understood this lesson. Just as an overview of what we have learned today, we have learned what heat energy is. Heat energy is a high kinetic energy of atoms, molecules, and ions. We've also learned what radiation is. Radiation is obviously the transfer of heat energy through waves where there are no particles. We've learned what the electromagnetic spectrum is. It's basically a spectrum of electro waves and magnetic waves, and there are 7 key points, which are obviously the ones that we've talked about in the acronym. Raw meat is very unsanitary except giraffes. We've also understood how infrared radiation depends on temperature. So the higher the temperature of an object, the more infrared radiation it will emit in a given time. And last of all, we've also learned what black body radiation is. Black body radiation is basically the radiation that effectively emits and absorbs radiation perfectly. So I hope you guys have enjoyed this video. Give this video a thumbs up if this does help you, and subscribe down below to the school station for more free science and maths lessons. Bye guys!